Right. There is a very important kind of feature that will generate a default route dynamically. So we are going to speak about that. You remember when we make an area as a stub area, that area gets a default route. If it is stub area, generating the default route is taken care by the ABR. The area border router, because that router knows that this particular area is a stub area. See, ABR is a member of both area 0 and the other area, which is a stub. So the router knows this area is a stub area, and I'm an ABR. So what that router does is it injects a default route to all these inside orange routers dynamically. The default route is dynamically injected as LSA type 3. If you go back and see those class videos, one class before, a class before video, I'll show that I was showing there when I type show IP OSPF database under the summary LSA type 3 0.0.0.0 given by the ABR, advertised by ABR. Now, when I make an area as a not so stubby area, I make this area as a not so stubby area because I got an inside router which is an ASBR. An inside router which is an ASBR. So I want all the routers inside all this pink to use the local ASBR to exit instead of using an ASBR which is in area 0. For that, I enabled not so stub area. Please focus. We are closing to the point. We are coming to the point now. We have configured not so stub area so that all type 4 and 5 is denied coming inside. So when I configured this area as a not so stub area, type 4 5 is not allowed to enter in. Okay. So how we are going to reach the internet? By using the local ASBR, I'm going to reach. But what if a web page, let's say Yahoo, that Yahoo's network is not available via this path? Assume, just an example. one particular destination, let's say Yahoo, is not available, is unavailable via this ASBR, but it is available here. It's available here. So what if some routes are not available if you go via this ISP? I'll call this ISP as Prime. If you go via Prime, some destination is unreachable. For example, Yahoo, which is available, which is reachable via internet here. Prime is the preferred one for this area, but the problem with the Prime is you don't have route to reach Yahoo. So what you can do is, please focus, very important please. What you can do is, you can go to this router and write a default route pointing towards this router. Statically, you write a default route pointing towards this router. And then go to OSPF mode on the same router. And say default information originate. When you put this command, OSPF will check whether I got a default route in the routing table. You already wrote default route pointing towards the other ASPR or the other router which knows to reach ASPR, internet ASPR. So after writing that, you say default information originate, so that the OSPF will confirm whether you have a default route statically configured. If yes, if there is a default route in the routing table, only then OSPF will have the guts, the courage, the boldness to advertise a default route. So now let's say this router is R10. R10 will say, hey, I am R10. I can take you anywhere that you do not know. So you can come to me. R10 is going to advertise a default route. R10 advertises a default route. But this time it is not type 3 LSA. It is type 7 because you have NSSA, no? So I think I have to show this to you all because okay, we'll see that in the command line. Now what I'm saying is not type 3. It is not going to be type 3. Type 3 is for the stub area. When you say default information originate, same like what this ABR does, a default route is given to all this router, but not as type 3 this time. Because this is not simple stuff, this is something extra. Default information originate, you generate it. You ask OSPF for additional help. So a default route will be given, again, condition. This router 10 should have already a default route. Only then it will advertise, R10 will advertise saying, I know the routes that you may not know, so come to me. So this router, when it pings Google, it goes like this because the route is available. When it pings Amazon, it goes like this. But when someone is pinging Yahoo, the router do not know the route, so it uses the default route and goes like this. For those networks that are unknown to this area, only they will trace this path, the internet path. See, without a scenario, knowing a topic is useless. This is the only scenario where this default information originate fits. Do you need to type default information originate here? No. Why? Even if you don't say, the default route is going to come, because in stub area, ABR is supposed to inject a default route. So the default information originate is not the default route that we used to receive as type 3. Okay, it is default information originate is only in these circumstances where type 5 is denied and you don't have route provided by the prime service, internet service, local ASBR. So in order to take the other internet via area 0, we can inject a default route from R10 so that this pink routers and the blue, if they don't have some routes, they can take the default route, climb up to the hill where other ASBR is, and reach the internet, which is on the top. Now, what if I forgot to write, or I am not willing to write a default route? If you are not willing to write a default route and you want a default route to be injected to all the pink routers, in that case, you need to use another one small word after this originate, always. Default information originate always, meaning even if there is no default route, you please generate a default route and give. But that's not good, okay? Why? What if this router generates a default route and gives, and for some destination X, 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 this router sends the packet and R10 don't have a route? It will get dropped. Unnecessarily it goes up to here and get dropped. So to reduce the burden on R10, to unnecessarily, allowing the packet come up to R10 and getting no, you need to have a default route so that the drop won't happen here. It will go and try till this outside. So always, so use it wisely when if it is really needed. If you have a logic like this, what we discussed, then you do it. Fine. Now next is sorry, that's all. There's no next. So you need to write statically a default route and then say default information originate. You no need to put always in that case. And the R10 is going to inject. I'm going to do and show you this quickly. So I'm going to use this topology. Say this area 100 is NSSA. Total NSSA. I'm going to do NSSA because this well suits an NSSA environment. Let's see the current situation on router 6. I would like to verify. Router 6, show IP OSPF. And it says that this is OSPF running, and okay, this is an NSSA. It's a NSSA, not so stubby area. But is it totally not so stubby area? I want to check that. Show IP route OSPF. If it is totally not so stub area, I should see a default route already to reach IA. See, but when I see IA, it means that it is simply a stub, not totally. It's simply an when I have n, which means not so stub area, and when I have IA, which is not so stub area, meaning it's only not so stub area. It's not totally not so stub area. If I would have made totally not so stub area, by now I will have a default route. Let me show you that. Show IP OSPF database. You see here. Right now I have type 3 LSA because it is only NSSA, not so stub area. Not so stub area will not filter type 3. Total not so stub area only will filter type 3. What is type 3? Other area routes. Alright, let's do that first. On R5, router OSPF area 100 is total, sorry, NSSA, no summary. This is what makes it as total not so stub area. Now if you see, you will see one default route in R6 database. You see type 3. There's a default route given by type 3. So total not so stub area, instead of learning IA routes, it will have IA default. Let us see that. Show IP route OSPF. You see, there is only one IA, and that is a default route given by your ABR, which is router 5 on this area. ABR is router 5. Now let me remove the total step. Totally not so step, I'm removing. Instead, I'll say area 100 is NSSA only. Now I'll start receiving the type 3 routes. See, I started receiving type 3 routes, and in the routing table I have IA routes type 3. Now pay attention. There is no default route. So if I don't have a network from R7, if I don't have some network from R7, but I have via R4, assume there is a network via R4 but not via R7. Maybe R7 has got some filter. Assume, just I'm going to create the simulation. I'm going to simulate the situation by filtering some networks. Maybe I'll filter 1 to 7. Okay, that 1 to 7 will not be available here. Let me do that first. I'll go to router 7. Okay, IP prefix list. I'll give a name, filter, deny. What? 17.16.0.0 greater than or equal to. Okay, slash 16 greater than or equal to another 7. I have to say minimum prefix length to match 16, 17, 18, 19. Also 19. 3 bits only. Then I can take out the 7. 1 to 7. 1 to 7. How many bits you need for 7? Writing 7 in binary. How many bits you need? 7 bits. Sorry, 3 bits. 111 is 7. Am I doing correct? This is talking about the subnet mask. So if I say 19, then it will be increment of 32. Sorry, this is not the one. This is not the way you should do. 24 minus 3 is 21. This is what I want to say. Okay, so I'm going to now use this under router EIGRP. I think I have EIGRP 10. Distribution list, prefix list. The word is fill in. What it does is, as the EIGRP update comes in, whatever matches with this prefix list is going to be filtered. Let's see. Show IP route EIGRP. I still have the roots. It worked. So all the roots gone. All the roots gone because the prefix list matched with all. Let me go and change the prefix list. I think I'm making some mistake here. As early as 16, 17, 18, 19. Let me say 19. First, I need to remove the older one. Even though I removed the older one, it says it's still. Yeah. Okay, now let me go to EIGRP router EIGRP10 and remove the distribution list. And then I'll come here and remove this. Okay, it does not exist. Good. So what? It says does not exist and it says exist. What is this? Let me check. Show IP prefix list. Okay, good, great. I like it. It is there. It's there. Now let me go to router EIGRP10 and put back that distribution list. See, I should have done distribution list in an easy way, but I was just making it complicated by using prefix list. Um, it's okay, good to learn things in a hard way. Okay, so you can see that it says dual algorithm neighbor resync OSPF processor lacks forwarding address of type 7, meaning we filtered some type 7. That's what it says. Sure. I think I'm making some mistake in the prefix list. So what I'll do is I'll remove this, and I'll just say only one network. IP prefix list. One network. Let me match. I'll say 10.1, 10.0/24. This is the only subnet I want to filter. 10. Okay. Okay. Now I'm expecting. Oh, now I understand why. I did not say allow other. We have a deny statement. Now you remember. In access list, when you deny, you need to say permit rest of the thing. That is what missing in the proof. That's why it was not working. Okay, anyway, now let me add that I realized that mistake is this. The prefix list that I just added is this. And I'm going to add a sequence number, fill, and then sequence number 10, permit any, permit rest. So I can say 0000/0. In access list, I would have done in an easy way, but I made things complicated by using prefix list here. I'm expecting now the other routes to come in. Show IP prefix list. I said deny only this and allow the rest. Show run section router EI. Okay. Yeah. Mm-hmm. Oof. For now, I'm not going to use filter list. I'm going prefix list. I'm going to remove this. I'll use it for another example. Let me use the access list to keep things simple. I'll remove this statement to distribution list also. So access list 10 deny 17 16 10 17 16 10